Hey College Algebra. In today's video we're going to be talking about quadratic functions. But before we get started with quadratic functions, I wanted to talk about the unit. And so this unit we're going to be looking at polynomials and how to graph polynomials. And today we're going to be talking about the quadratic and how we're going to graph it using transformations, vertices, and intercepts. We will also use our graphing calculator to find the quadratic function that best fits a scatter plot. So let's go ahead and get started. First off, from last unit, or from Unit 2, you guys have already worked with quadratics such as this one, using transformations. You know, h and k being your vertex, a being the stretch. But in this unit, we're going to start talking about quadratics in that form. Now notice how they both have an a in it. Well, that a is actually equivalent in value, and that's not by coincidence. And that's because we can complete the square in this function to get this. Okay, so check this out. Let's go ahead and complete the square for this function here. So first thing we want to do is take this 2 out of the 2x squared and minus 4x. So 2x squared minus 2x plus 5. Well, now I'm actually going to erase this because we're completing the square, right? And so there should be a gap right here. We're going to add our term. Now what goes into that blank spot? So if you guys remember, that's just going to be equal to b over 2, half of b squared. And so you can rewrite this. So half of negative 2 is negative 1 squared. It's just going to be 1. Okay, but we just added this 1 out of thin air. So we need to correct our function in order to keep it accurate, to keep it consistent. So here we added 1, but it's multiplied by 2, so we actually need to subtract 2 from the total function in order to keep it consistent. So we'll subtract 2 from the 5. So we'll get 2x, and now we can actually factor this guy, right? Because we've completed the square. So 2x minus 1 squared plus 3. And now we have transformed it into a function that we can easily graph. We've got our a, our h, and our k. Okay, so that's one option to graph parabolas. Let's start looking at the other one. So just as a reminder, I also on this slide have what h and k represent, which is an intercept, or a vertex, and a represents the stretch. But what if we have a function in the form of f of x equals this? So we have to find the vertex, right? Which is this point right here. How do we do that? First off, we have to find our x value of our vertex. And so before, h was our x value of a vertex, but here we just say that x is equal to negative b divided by 2a. And so once we get that value, we plug negative b over 2a into both of our x's, and we'll find our y value. And so we'll get the point x comma y, which will be our vertex. Okay, now what is this line of symmetry? So this line of symmetry actually just lines up with our x value of our vertex. So x is equal to negative b over 2a is the vertical line that goes through our vertex. Okay, now that we've come up with the vertex, in order to graph these quadratics, we actually have to find the x and y intercepts. So to find the x-intercept, what we have to do is plug in 0 for y or for f of x. Now, we can solve for these x-intercepts by either factoring or using the quadratic formula. Either or, sometimes you won't be able to perfectly factor, as you guys well know. Then the y-intercept is super easy. All that is just this plus c at the end, because we put zeros in for our x's, and all we'll be left with is c. So we found our intercepts and our vertex. Let's go ahead and go to the next page. Just go through it one more time. So, in order to find our vertex, our x value is equal to negative b over 2a, and we plug negative b over 2a into our function. Now, how do we determine if our parabola has a maximum or minimum? So, we have a negative a out front. We'll end up having it opening downwards, like this graph right here. And so when you have a negative a, we'll actually have a maximum. And it's opposite for a positive a, so then we'll have a graph that opens up, and therefore we'll have a minimum. Okay, so there's actually one more point that we can find on this parabola. Check this out. If we have our y-intercept here, this line of symmetry is called the line of symmetry because this line represents a mirror of the parabola. It's essentially dividing the parabola in half. And so the distance from the y-intercept to the line of symmetry is equal to negative b over 2a. And the same goes for the distance between here, the line of symmetry and this point on the opposite side. And so this value here, if you add up both your distances, it will get you your x value. And these should also be positive, right? Because yeah, we're not going to the left. Okay. And then our y value is just going to be the same from our y-intercept. There we go. All right, so let's go ahead and graph this function as practice. Does this parabola have a max or a min? So it's positive a, right? So that must mean it's going to be a minimum. Now let's go ahead and find x. X is equal to negative b. B is equal to negative 2, so it's just going to be 2, times 2 times a, which is just going to be 4. So this is equal to 1/2. And you're not always going to get perfect answers, so that's okay. Actually, 1/2 is a perfect answer. I meant to say that we're not always going to get integers as answers. And so we plot the point x is equal to 1/2 and draw that vertical line, our line of symmetry. Okay, so now somewhere on this line of symmetry is going to be our y value for the vertex. So we plug in 1/2 for all of our x's. So we get 2 times 1/2 squared minus 2 times 1/2 plus 4. And so when you do this, you'll end up getting 3/2 as your answer for y. Okay, so 1, 2, 3.5. There's our vertex right there. Okay, now that we have our vertex, all we have to find is our x-intercept and our y-intercept. I want to start off with the y-intercept because it's so easy. It's just this last value here. So I'll put a 4. And so it's going to be the same on the other side of this line. So I'll put another point there. Cool. So we've now decided where our parabola is going to go. It's going up. So then, is there even going to be an x-intercept? Well, the answer is no, right? Because look where we're heading with this parabola. We're heading up this way. So we can't actually graph our x-intercepts because we'll get some imaginary number. So for this example, we're only able to graph 3 points. Okay, so let's look at this function right quick. Without even graphing, can we determine if there is a max or minimum? And the answer is yes, right? Because we had to look at our a, determine if it's positive or negative. So it's negative, therefore it's going to be a maximum because our parabola is going to look something like this, opening downwards. Okay, now let's try to find our maximum value or our vertex of this parabola. And so x value is equal to negative b over 2 times negative 2, which is just going to be equal to, be equal to 2. Okay, so we got x is equal to 2. What we have to do now is plug 2 back into our formula. So f of x is equal to negative 2. Okay, so our y value here, or f of x, this is going to be 5. All right, and so that's our point. Our max is going to be 2, 5. Okay, so I feel like you guys were all very comfortable with that, but I want to talk about something we haven't really mentioned before, and that's determining the scatter plot or the line of best fit of this scatter plot. So to do this, we're going to use our calculators. All right, so now that I have my calculator out, and by the way, just as a heads up, all you guys should have your calculators out because doing this along with me is the best way to learn. And so first off, when we're trying to determine a scatter plot of the data, what we want to do is go enter in our data. So to do that, we go to Stat, click Enter on Edit. Let's go ahead and put everything in. And I'll go ahead and pause the video, and you guys can do this as well. All right, so got all my points into the Stat Edit. So let's go ahead and figure out what this looks like graphically. Just go ahead and graph. Oops. So we're going to want to clear everything out of our y equals first. Okay, so I'm going to go ahead and pause it. All right, now that everything's cleared out of our y equals, we go up to plot 1, press enter, and now go to graph. Okay, but now we don't see anything, right? So what's the problem? The problem is that we have to adjust our window. So I've already messed around with the window a little bit, so I know approximately where the parabola will be. So I'm going to go ahead and change that. Okay. So let's go ahead and check out this parabola. Okay. So what does this look like? Now, before when we worked with scatter plots, we had to decide whether or not the line, what its slope was, right? Because we were working with linear lines. But now you can tell this one clearly isn't linear. And in fact, it looks something like a parabola. Now, another way to find your window of best fit is to go to zoom 9. But for right now, I just decided to adjust the window. So, okay, we decided that it was going to be a parabola. Also, if you guys ever have a hard time spelling parabola, think of it as parabola. It always helps me spell it. Okay. Now we've found what the shape should be. Let's go ahead and determine what the function is. So to do that, oops. Go stat. Oops. Then we're going to scroll over to calc. Now we've worked with linear regression before, but now since it's a quadratic, we're going to use quadratic regression. And we'll press enter. And it'll give us our A, B, and C values. All right, so I went ahead and paused the video and wrote down the function right here. Now the last question asked us to predict the miles per gallon for a speed of 63 miles per hour. So our speeds were our x value, right? So what we'll end up doing is throwing 63 in for all of our x's. Now this I would expect you guys to throw in a calculator, but obviously if you do it by hand, that's just extremely impressive. So go ahead and pause the video and do. Okay, so when I plugged it into the calculator, I ended up getting 29.029. Okay, and so that's how we work with scatter plots and using quadratics to find the function of best fit. So in today's video, going to go back to the original slide, today's lesson we went over how to graph quadratics using transformations as one option or finding the vertex and the intercepts as the other option. And then at the end we used our graphing calculators in order to find the best function to fit a scatter plot. All right, so I hope this video was beneficial for you guys. There are nightly questions posted below, and I'll see you guys next class.